Good morning, Scott here, known as Cantaloupe to some online, and I'm bringing a video to you on a subject that's interesting to me. It might be of interest to you or someone you know, and I want to go over some introductory electrical engineering terms for anybody who might be interested, if you're a hobbyist or if you're planning on taking a class or if you want to build something someday. They have kits that you can buy, actually. They used to be for sale at Radio Shack when there were Radio Shacks. You can still get them online, various places, Amazon, some Chinese retailers. They have these things for sale. But I want to go over some terms which may be familiar to a lot of people, but were confusing to me for a long time, and I finally learned the meaning, and I want to go over some of this stuff in a few minutes. So there are terms like voltage, amperage, resistance, capacitance, and all of these things. They have very clear meanings in terms of electrical engineering. I want to disambiguate for people who have an interest in this stuff, just at a really introductory level. This isn't going to be an advanced exploration of the ideas, but voltage is analogous to, and you may have heard this, the amount of pressure on the circuit, whereas amperage is analogous to the diameter of the pipe, if you want to think about it in terms of fluid dynamics or some kind of water pipe. So amperage is going to determine, it's going to be pivotal in determining your current, how much current there is, which is just the amount of electricity flowing. But obviously, if you have 0 volts, it doesn't matter how many amps you have, there's no current because there's no pressure. Remember, voltage is pressure, how much pressure there is. So, for example, you have like a taser or stun gun, which is wired to magnify or amplify the voltage, but is usually operated by just some small batteries. So there isn't going to be a large source of amperage. You know that already. It's a handheld device, and you can wire it so that you multiply the voltage. And this is how they do it. They transform the voltage with a circuit that brings the voltage up to the range of about 50,000 or thereabouts, which when it comes in contact with human skin or flesh, that you will feel it for sure, and that's the idea. But it won't kill you because there's no amperage, almost no amperage. However, there are applications where the amperage it must be higher because there's work that needs to be done by the electricity, such as in an electric motor or starter of a vehicle. Consider, in fact, what got me on this subject was I just picked up some litter. I hate finding these things around. This is a common vape that people pick up in the stores, and they bug the heck out of me because I find them all over the place. And this one's still operational. It's got the switch and the battery all charged up, and somebody just threw it on the side of the road. It's got a USB Type-C port to charge it, and USB, whether it's the original format or Type-C, it uses the same electricity. It uses between 5 and 12 volts DC current to charge, and it's got a wide margin of tolerance. You can go above and beyond, 8 volts below or above, I mean. And what's interesting to me is even this small device, which is similar, obviously, to your phone or tablet or camera or whatever, it uses the same exact voltage, that is to say up to 12 volts, that a car battery uses, and same type of electricity as direct current, DC current. So what makes something like this, a tiny little device, different than, say, a big monster battery that will start a diesel truck? Because they use the exact same voltage potentially. It's the amperage, like I said. So you can think about amperage again as the size of the pipe, how much current is going to come through with the amount of voltage you give it. So it's the same volts, 12 volts in this case, but say, many amps. I don't know off the top of my head how many amps a truck battery has. I'm guessing, over 10, so somewhere in that neighborhood. It's a lot. Well, a lot in terms of devices and electronics. So I mentioned some other terms, not to go on and on. There's voltage and amperage, which I've covered, and there's capacitance, which is the ability to store a charge. So they have capacitors, which is a small component that you can charge up, and then they discharge instantly. All the capacitors I've ever read about, they discharge instantly, and that's what they're good for. So you can put them in a circuit where they are triggered by something, and then they release their charge. and it's useful for certain things that are used in old televisions, the old CRT televisions, the big back televisions that you may have seen. And there's also resistance, which is how you can regulate current. If you put a resistor somewhere on the line where your current is flowing, it will reduce the current. It will turn it into heat and also slow the flow of electricity to the point where you can regulate it very specifically. If you have a source that is perhaps unstable or it's unpredictable, you might have a little bit more than you need or a little bit less than you need. You can get it precisely how you need in terms of voltage, I believe, with one or more resistors in your circuit. So it's just some interesting stuff. So resistance is measured by ohms. Ohms, you may have seen the omega symbol, the Greek omega symbol, that symbolizes resistance in a circuit. Capacitance, I don't know all of the symbols by heart, but you can easily look them up. And if you look at a wiring diagram, and they have all these funny symbols on them, they all mean some component, some electrical component. And at 6 minutes, I'm just going to wrap up with a difference between DC and AC current. So DC is what I described. It flows in one direction. Direct current goes in one direction throughout your circuit, and it will potentially turn a motor or a power device, such as with USB. It's DC current. Whereas you have AC current in your wall outlet, typically in the order of 110 volts. 110 is the common household voltage. Unless it's for a large appliance, you might find 220 with different amperages based on the needs and the location of the outlet. And the reason why we use AC current at all, which is it's kind of interesting to me. There was some big debate that I heard about when the architects, the original designers of our modern electrical grid, when they were debating what was proper and useful, it wasn't obvious to them. And in fact, there was a lot of controversy as to whether wall outlets in homes should be DC or AC. And obviously, maybe it's not obvious, but we use AC now. Alternating current. It comes in at 60 hertz, at 60 cycles per second. That's the positive and the negative flip 60 times a second. And you may notice this actually if you plug in an old light, like a fluorescent light, you're going to hear it hum. That frequency that you hear, that humming noise, is exactly 60 hertz. And you can check this, it's true. So, and the reason for this is because AC current, my understanding, is the default output of the way in which most electricity is generated at the plant. They use steam turbines. They use a number of ways to turn a generator, an alternator, if you will, to create this current, and it just so happens that it comes out of the systems that they use that are the natural output of the easiest systems that they have always used comes out AC. It flip-flops back and forth. So they thought, instead of trying to convert all this AC power that's coming out of the power plants to DC, because DC is arguably safer and more consistent and easier to use, they said, let's just make it the standard. We'll make most devices, all devices that you plug into the walls at your at residences and households, they will just accept this and expect it to be AC power in the order of 110 volts. And they have been ever since. So it's just an interesting factoid. There's a lot more, obviously. It's a big subject, a huge research field. If you go into it, if you have an interest in electrical engineering, I'm by no means a credentialed expert. I don't have any certification. But I do have an interest in electrical engineering a little bit. And I've built some things over the years, nothing too spectacular or worthy of describing here, but if you have an interest, take a class, read a book. You can find tons of information online, but of course, don't shock yourself. You can easily die with enough voltage and amperage, so watch out. Don't be messing with your wall socket. This isn't an invitation to do that. So consult an expert if you must. Reach out if you like down below with questions or comments. Thank you.